In this video, I'm going to be going through some of Google BigQuery's free datasets, kind of giving an intro on how to get access to those, how to use them roughly, and then getting into two of them somewhat deeply here. So I have Google Rising Trends and then Wikipedia 2024. Here you have kind of a finalized BI tool, we'll say, in Power BI. I got a tab for the Google Trends dataset and a tab for the Wikipedia datasets. Google Trends one is really more of a poll. It's pretty straightforward. And then with Wikipedia, I did a few more relatively advanced processing steps with this data. Added in some K-means clustering attribute to basically use natural language processing to go through each of these titles of each page and sort of look for ways to group them together. And so taking a step back here, getting into Google BigQuery, a little bit of background on that. So they do offer access to a variety of public data sets that are freely available for analysis. They cover a wide range of topics. So as you can see here, like once you sort of get into that BigQuery public data, we'll say database, you have access to all of these different, I believe we'll say schemas, and within those different tables. So you can see like census data already, like COVID data, like tons of different data sets, tons of different relevant and useful data sets, and you can see where I've sort of dug in. But there's a lot here to play with. We'll say there is limitations around how much you can do with this data. So you have 1 terabyte of free queries per month, and then there's a storage limit up to like 10 gigabytes if you actually want to store data. Further, there is some steps to get this set up, especially if you're trying to query or run these queries out of like Jupyter notebooks, like I'm doing with Wikipedia data sets. So you kind of got to go to the website for Google Cloud homepage and sign in or create a Google account, right? Set up a project, and then once you actually get into like connecting to, let's say, like Jupyter Notebook, you have to what's called authenticate your session. So you create a service account, go to Google Cloud Console to do that, create or download a JSON key, and then set the environment variable. But that's sort of the rough overview of how to get in. Now that I've given that quick lay of the land, here's, of course, if you've never used Google BigQuery before, the interface, the text editor. I'm choosing to look at two different tables here. Just trying to kind of build a BI tool that gives me like just a rough idea of rising trends. Two of the data sets that stood out to me was the top rising trends, which is from Google Trends, and then Wikipedia's Pageviews for 2024, looking at the ones that have the most engagement, kind of ranking that. Here we have, of course, the top rising trends. I'm going to go and run that. You'll notice I have sort of this step on here. Because of that, like 1 terabyte limit per month, you really, if you're just sort of exploring a data set, you want to be very conscientious of your limits, or really just pulling like samples of data versus the whole data set. An easiest way to do that for me is just to work off of the date field that's in that data set. So here you'll see, pulling just the last day worth of refreshed data. Yes, it has a lot of historical data going back pretty far, going back many years, I think like 5 years, something like that. Here are 25 trends as of now. Here's kind of all the history of them. And then you can look at how this score field here sort of fluctuates over time to see relative popularity of each of these terms over time. So you'll notice everything else sort of remains static, like the percent gain will remain static, I think, throughout the entire data set. Really, it's just this score that changes as you look backwards. And then you, of course, have your DMA breakout, which is super helpful to sort of localize the trend for targeting purposes. And then the rank, of course, the rank being is just within the top 25, number 1, number 25, right? Intuitive enough. So that's that data set. And I'll quickly show you this one as well. So this Pageviews for Wikipedia for 2024. It's a much, actually, larger data set relatively than the previous one we just showed. For that reason, it won't even let you run this one without filters, specifically on date hour is what it demands. If I just try to select all from this and then like limit it to like 100, it won't let you do that. It'll say, cannot query over this table without a filter over columns date hour. So rerunning this, and I have also have a filter to like English language. This Wikipedia data set has, I think, variety of languages. There we go. So this is, as you can tell, very straightforward as I'm pulling it. And then if you want to see like job information, you can do that under job information, of course, and then byte scanned 3 gigabytes just to see how much of my 1 terabyte for this month I just took out with this query. Back into here, I'm going to go back to the Google Trends data set. So I'm really just bringing in a BigQuery source. So a new source and the transform query editor, Power BI. If you just type in BigQuery, you see that option. So that's what I've done here for my Google Rising Trends. I click on the gear next to source and applied steps. You can kind of see a little more detail about how I've done that. I had to just essentially say project ID is BigQuery public data, and then put in my query. So nothing too complex, and it just pulls it in. I didn't add any extra steps, just brought it on in because it's honestly a pretty ready to go data set as is. Yep, so I just kind of created a table with some of the attributes that I was interested in. You can see the rank 1 to 25. You can see the average of the score for each of these. And then you can see the average of percent gain. And that percent gain is really what's determining the top rising trends rank here. So one has the highest average percent gain because it's been growing. And this is looking at data that was refreshed as of yesterday. So we have this Taiwan earthquake, plate adder, stuff on digs, Taiwan, earthquake. I know that, as of when this video was recorded, there was an earthquake in New York, right? So everyone, I'm sure, is searching, wants to know more about that. DMA breakout here, so you can sort of see where each of these trends are localized the most. So if you look at the bottom here at this filter on date, you can see that we have quite a bit of history in this data set currently, in this view currently. For the sake of demonstration, at least initially, I'm going to filter this all the way to the right to just the most recent day of data we have. So for the top 25 rising trends, just give me the score as of the most recent refresh date. So really going to have more specific insights around recency, at least as of when this video was recorded. So you can see now we're just considering scores by DMAers in general for that most recent refresh date. So now if I were to click on one of these, I'm going to pick one that I think is going to be a little bit more specific to different DMAs, a little bit more localized. I'm going to click on tornado warning. You can see how there is a lot of variance now between different DMAs. And so here we have Ohio, right, with a lot more tornado warning score than other DMAs. And that makes sense because Ohio, as of when this video was recorded, those people over there, they had a lot of tornado activity not even like a week ago. So that makes sense, and I think it's validating. Kind of backing up here though, I'm gonna put this trend all the way back out because I want to see now what the historical trend has been for the term tornado warning in Ohio. So I'm gonna do a little bit of cross filtering here. So now it's filtered just tornado warning, but it's across all DMAs. I'm gonna scroll over. I'm gonna select just Ohio, and just to show you that it's done that. Everything else is sort of phased out, let's say, and then just the Ohio DMAs are selected. And you can see the trend, and you can see how, within the last 12 to 14 months, a lot more relative average score for tornado warning in Ohio compared to previous time period. And that's something I've been hearing as well. It's also validating because people I know in Ohio are saying that this year it's felt like there's been a lot more tornadoes than before. So that's, pretty much what you get with this Google Rising Trends data set. Very straightforward, but very valuable, I think. You really can just keep a pulse on the rising trends and easily localize them with this data set. So very useful. Getting now into the Wikipedia data set. So I guess gonna take a step back here, and I'm gonna show you some other processing steps I'm actually doing in Python before bringing this data set into Power BI like I have with the Google Trends one. So I'm going to navigate here to a Jupyter notebook that I have. So essentially what I'm doing, I'm bringing in my packages, of course. You can see a variety. Bringing in like some of what you would just expect when working with Google BigQuery, but some other ones as well that are also pretty typical, like Pandas. But then I'm bringing in a lot around natural language processing and K-means clustering. So I'll get more as to like how that's working in a minute, but essentially, when I look at this data set in and of itself, if you recall, it's very simple, right? It gives you like the title, it gives you dates, it gives you views, but it doesn't really give you like a category. I was noticing, and I was looking for a way of like, how can I kind of parse out these titles into different types, essentially different categories. And I was noticing that a lot of them did contain indicators in parentheses, like film, audio, book, things like that, artists. And so I wanted to see if I could, without having to get like super manual with searching within, the values of each of these titles and just grabbing all the ones that contain film. I don't know the full trends in big data set. I was seeing if I could just like process it with some natural language processing packages, and then have that pick up on like those common words and then bucket them accordingly. And so it did end up working out okay, and I'll get to that in a minute. But back to sort of how that's taking place. So I'm putting a query, Google BigQuery, in here and running that query. So it's really just connecting back, and running it sort of out of here and bringing the results back into my Jupyter notebook. To do that, as I mentioned before, you kind of have to have like credentials, and you have to go through some steps to get the key and then do a download and then create like a reference for that. So here you can see I have my reference, and you set the client, and then you run your query. And so the query is a little bit different. So the query is a little bit different than what I showed before. I'm kind of cleaning it a little bit before actually running anything on it. Down below, I'm moving like file, category, talk, Wikipedia. These are kind of what I was noticing, like just some sub pages within Wikipedia, not really like a page that someone would look at in the way that you kind of would every day. But essentially, otherwise, it's the same. So title, start date, aggregating the views, looking at just a past day here, but you could expand that out to like look at more history. So getting into kind of next step here, this is where I'm really bringing in that natural language processing step. So really kind of what it's doing here is it's stop word removal, you'll notice, and those are just like common words that usually don't carry much meaning, like and, the, to reduce the data set size and improve the analysis focus. It's kind of getting rid of some noise in there, and that isn't really going to be helpful for the categorization that I'm going for. And then tokenization, so splitting each title into individual words or tokens, and then it's rejoining all the tokens. So the pre-processed titles are then converted into this TF-IDF matrix using a scikit-learn package, and it's a statistical measurement used to evaluate the importance of a word to a document in a collection or corpus. It increases proportionally to the number of times a word appears in the document, but is offset by the frequency of the word in the corpus, which helps to adjust for the fact that some words appear more frequently in general. And then we have a step here that converts the collection of raw documents into a matrix of TF-IDF features, or inverse document frequency. That's what IDF stands for. Definitely read a lot of that off of just some documentation here, but wanted to not just throw the code at you, but give you some degree of explanation on what this is doing. But essentially, it's just looking at the values for title and then processing them and to be more useful for categorization that I'm doing. Down here, we get into like the elbow method, because I'm using K-means clustering to kind of create my categories here. And with K-means clustering, there's that heuristic where you can just create the elbow chart and then choose where it sort of dips off to kind of determine when additional clusters are no longer going to be valuable to the model. Specifically, how this is working is you can see it's plotting the number of clusters against the SSE, or the sum of squared errors. So this is a measure used to evaluate the performance of the clustering by the K-means algorithm. And so what it's doing specifically is it's calculating the sum of the squared distances between each number of a cluster and its cluster centroid. So, I can see that the kind of elbow is at 8. And so you can see here that I chose 8. So what I end up taking out of here ultimately for the final data set that's pulled into Power BI is just the K-means cluster set to 8 clusters run on the output of this query. And so I'm going to go back, kind of show you that step. It's a different kind of connection. So this is a Python script connection rather than a BigQuery connection directly. So you can just go into your new source, type Python, and it gives you that script option. So with this, you can really put whatever you want in this script text box. It just needs to output as a tabular data frame. And then that result will populate in the preview of the transform query editor, just like any other tabular data that you would pull into Power BI. So you can see I'm just kind of bringing in my packages, got my credentials step, running my query, running my K-means cluster on top of that with 8 clusters. And so that bottom step here kind of pulls in this with my cluster. Clusters aren't really named, but I could set a name once I sort of look at them and figure out what they are visually. So push that through. Back to the tab here, you can see that just have my table. This is pretty much what I showed before as just my output of my query kind of straight up, which is, so you can see it's like the output of the query I ran before without any additional processing, where I just have like the date, the title, some of the views descending. So, I mean, this in and of itself is interesting just to see, like, in general, as of like yesterday, what were the most popular in terms of views, Wikipedia pages. That's in 2024. That's a little dark, but there have been some recently. And then we have variety, a mix of different types of titles. So you can see where it might be helpful to have some categorization. Like if I click on 4 here, 4 is by far the biggest one, and it's because I think it does contain a lot of like the sort of front pages of Wikipedia, some other pages that could be filtered out that just have a ton of views and sort of blow that out or inflate that count. I've removed them in the table, but not in the box chart here. But if I click on this, you can see it's a little bit cleaner now. It does contain a mix still, but it's, all things that don't really have, at least for the most part, a descriptor next to them, like they're not part of a category, at least as being defined by Wikipedia. But if I go to like 6, you can see all these other ones that contain like film or novel for the most part. So it's a lot of that kind of media. And then so you can have more of an apples to apples comparison across different titles categorically. So I guess it's the portal for events. I just ignore that. We could filter that out actually. But then we have like film, like Monkey Man, Three Body Problem, iRobot, Civil War, Imaginary. So you can kind of get an idea of like what's some like popular films right now, some popular novels right now. So yeah, if I had to name this one, I would probably call it like novel/films. I'd keep it simple. Here we have albums. I think it's really just albums, but you can see like some really popular albums, at least as kind of being catched here, at least as of what's being caught here by this clustering. So Ohio Players, Bad, Father of the Bride, Eternal Sunshine. So really 6 and 2. I think I'm doing a really good job of actually creating useful clusters here. And I might continue to dial this in and see how more sophisticated I can make this clustering algorithm that we're using, and in terms of how it outputs useful clusters for this data. Hope this was informative. I'm going to go ahead and just save all this and include it in my GitLab, and the link of that will be in the description of this video. So if you want to download this file, you should be able to do that, and it should work for you. You just have to replace some of those credentials steps with your own credentials. But then it should all just work for you, because this is all public data, free data anyone can access. Just got to be cognizant of that 1 terabyte a month query limit. But otherwise, thanks for watching. Talk to you later.